Hello friends, today we are going to see the simulation of 3-phase 3-wire UPQC. If you want to buy this simulation will cost you around 7,000 rupees, and if you want to buy this project, you can contact me on the number given in the description box. So let us begin with the simulation. So here these are the control strategies for the UPQC. Means UPQC consists of two parts. One is a DSTATCOM and another is DVR. In this, the DSTATCOM will be used to compensate the reactive power. It will mitigate harmonics and it will make the unbalanced load current balanced. And DVR will compensate the sag and swell in the voltages. So the if there is a sag and swell coming in the voltage from the source side, then the proper voltage will appear on the load side. Means if there is the common voltage is 240 volts, and if the voltage is reduced, suppose it is the voltage from the source side is coming 200, then on the load side the voltage will be 240 volts. So I will move on to the simulation. So here you can see this is the simulation. The one highlighted is the control strategy for the DSTATCOM, hence the second highlighted is the control strategy for the DVR. This control strategy I will not show. You can buy this project if you want to see the control strategies. So this is the structure of DSTATCOM and DVR. This portion is of DSTATCOM and this portion is of the DVR. DVR will be connected in series with the system and DSTATCOM will be connected in parallel. So we are going to see here that is reduction in harmonics. Then the unbalanced load current will become balanced on the source side. Suppose here we have taken the load as unbalanced. Here we have given uh, active and reactive different values for the active and reactive power. So the current on the load side will remain unbalanced and the current on the source side, which we have measured here, will be balanced. Here we have used a bridge rectifier to create a harmonics in the system, which will be mitigated on the source side. Now for the DVR, we have here given the change in the voltage amplitude. Means we have changed the voltage. Means we have first that the 1 per unit voltage will be there, then it will be reduced to 0.8 at a 0.3 second, then it will go to 1.2 per unit. Means there is a swell in the voltage at a 0.4 second, and 1 per unit voltage will continue from the 0.5 second. So first of all we will see that how unbalanced current becomes the balance. Then so this one is for the load current. So as we have used the unbalanced load, the load current will be unbalanced. So I will show you the diagram. As you can see here, the load current means the the yellow color one is lower, y one is greater amplitude. So there is an unbalance in the load current. And now I will show the current on the source side. So this is the current on the source side. As you can see here, the source current is perfectly balanced, as you can see. Now we will move on to the second one, that is compensating the reactive power. Suppose if we are providing the reactive power, means the load is taking the reactive power, then the voltage and the current on the load side will not be in the phase. I will show you the load side voltage and current. So as you can see here, this is the voltage and current on the load side. It is having the harmonics and it is not perfectly in the phase. So now I will show you the current and voltages on the source side. So these are the voltage and the current in the source side. As you can see here, the voltage and the current are perfectly in the phase, means there is a 0 degree phase shift. So the volt reactive power is being supplied by the DSTATCOM. Now we will see the reduction in harmonics. So we will see the FFT analysis on the load side current, and then we will see the FFT analysis on the source side current. So I have given the name for the load side as load side current as IVL. So now we will display the harmonic analysis. As you can see here, THD in the load current is 21.48%. Now we will see for the source side. I have taken the name as IVS. Now we will display the harmonics in the source side. Now it is reduced to 2.48%. You might be seeing here there is deep and swell in the deep and swell in the voltage level. I will show you later. So sorry, I have shown earlier for the voltage analysis. I will show you for the current. Here you can see that the THD in the current is reduced to 3.34%, and in the load current it was around 21.48%. So there is a reduction in harmonics. I have shown you the three things, that is reduction in harmonics, making the load current balance on the source side, and the reactive power compensation by showing you the in phase voltage and current of the source side. Now I will show you how the voltage sag and swell are compensated on the load side. As we have given a sag and swell in the voltage, we will see here. As you can see, at a 0.3 second we have given a zero point 0.8 per unit swell, means the voltage is reduced to 0.8 per unit, and at a 0.4 second the voltage is increased to 1.2 per unit. So we have provided here sag and here swell is provided. Now what happened is the DVR will compensate for the sag and swell. So I will show you the load voltages. This one which I am opening is the load voltage. As you can see here, the voltage is has no sag or swell. As you can see here, at 0.3 second there is no sag is appearing, and at 0.4 second there is no swell appearing. So the voltage are perfectly fine on the load side. So this was the simulation of 3-phase 3-wire UPQC, and if you want to buy this project you can contact me. I have given my number in the description box. Thank you very much for watching this video.